Hello and welcome to problem 3 in my Calculus 3 or multivariable calculus problem solving series. In this video, we're going to look at how to find distance from a line to a point in 3D. Let's go ahead and look on how to do it. Alright, so we want to find the distance from a line to the point in 3D. So remember that a line consists of a vector and a starting point, and this vector points in the direction of the line. And we want to find the distance d from this point to the line, and it will form a 90-degree angle because that is when the distance will be minimized. So let's go ahead and do it. So to find the distance from this point to the line, we're going to use the area of the parallelogram that these two vectors form, because the area of the parallelogram is going to be the distance times the base of the parallelogram. So this vector is going to be PQ, which is the vector from a point P on a line to a point Q. The point Q, which we're trying to find the distance from. And the blue vector is going to be the vector V, which goes along the line and points in the direction of the line. So using those two vectors, we can find the area of the parallelogram in two different ways. The first way was just multiplying the base times the height, and this is the standard equation for the area of the parallelogram, and this will give you the area. The second way will be the magnitude of the cross product of these two vectors. The magnitude of the cross product of those two vectors will give you the area of the parallelogram. So we can say that the magnitude of the cross product of those two vectors is equal to the magnitude of that vector times the distance. So to explain a little more on why the magnitude of the cross product is equal to the area of the parallelogram that the two vectors form, I've drawn these two figures here. So imagine you have two vectors, v and u, and you take the cross product of the two of them. The magnitude of the cross product is going to be equal to the magnitude of u times the magnitude of v times the sine of theta, which is the angle between them. This is just the definition of the cross product and its magnitude. The definition for the area of a parallelogram is A is equal to the base times the height. So in this case, the vector u would be the base, or the magnitude of u would be the base, and the height would be the magnitude of v times sine of theta. And so when you multiply both of them together, you're left with the area of the parallelogram. So that's why when you take the cross product and you take the magnitude of it, you are left with the area of the parallelogram. So going back to the picture here, we can see more clearly. We can see that the magnitude of PQ cross V is going to be equal to the area of this parallelogram, or in other words, the distance times the base, and the base will be the magnitude of V, which is this vector in blue. So this will give us our equation to solve for D. Alright, so solving for D will give us this equation here. The magnitude of the cross product between PQ and V divided by the magnitude of V will give us the smallest distance from the point to the line. So let's go ahead and try an example. So this question asks us to find the distance from this line to this point. So here I've drawn the line, and the vector v is going to be this vector. So v is 2i plus 4j minus 9k, and this vector goes along the line. And q is the point 2, 6, 6, and we want to find the distance between q and the line. So the first step we need to take is to find pq, which is the vector that goes from p, our starting point on the line, to q. And p is going to be this point here, 7, 5, 5. And to find pq, we need to take oq and subtract op, and it will give us this vector here. So we go ahead and do that, and we get pq equals negative 5i plus j plus k. And we also have the vector v. So now let's go ahead to the next step. So looking back at our formula for d, we need to find the magnitude of pq cross v. And to do that, we're going to first find pq cross v. So we're going to do this the same way we did in the last video by taking the cross product of the I components, the j components, and the k components. And it's going to give us this vector here. Then we need to take the magnitude of the vector, and we do that by taking the components squared and then taking the square root of that. And we get the square root of 2,502. Then we're going to take the magnitude of v, which is again the adding up all of its components squared and taking the square root of that, and it's going to give us 101, the square root of 101. So then, using our formula, we know that d is going to be the square root of 2,502 divided by the square root of 101, which is about 4.98. So let's go ahead and look at another example. In this example, we have the same line, but this time the point is 11, 13, negative 13. So we're going to do the same process as last time. So we're going to find PQ, and PQ is going to be OQ minus OP. And that's going to give us this vector here, 4i plus 8j minus 18k. And we have the vector v, which goes along the line, which is 2i plus 4j minus 9k. And so now we have to find the cross product to find the magnitude of the parallelogram that these vectors form. So here's our formula again, and we see that we need the cross product of the two vectors and its magnitude. So to find the cross product, you set this up again, and you take the you cross multiply the I components, j components, and the k components, just as we did last time. And you're going to get this. And it turns out that this vector is actually 0. So it's 0i plus 0j plus 0k. So that means that the magnitude is also 0. And the magnitude of v is this, we did this last time as well, and it's going to be the square root of 101. So when we calculate the distance is going to equal 0 divided by the square root of 101, and that's just 0. Now, what this means is that because the distance is 0, it means that this point actually lies on the line. So it is part of the line. So here I'll show you what I mean. So here's our line, and here's Q, and here's V and PQ. And these are parallel vectors. And when you take the cross product of parallel vectors, it gives you a vector with magnitude of 0. So yeah, that was another example, and this time the point was on the line. If you guys enjoy watching this video, then make sure to like and subscribe, and also comment what video I should do next. That's all for now. Thanks for watching.